Okay, one other thing I want to talk today before we stop, flux. We talked about flux yesterday. What did we say flux was? Remember my balloon example? How much stuff is coming out of the balloon through the surface? Okay, so flux is basically how much stuff is coming out of the surface. When we talk about electric field specifically, flux defines how many field lines pass through the surface. So if I suppose this could be my surface. If I have to define how many field lines pass through here, three, right? There's 3 field lines that are passing through the surface. How did you know that?
There's 3 going in and 3 coming out.
There we go. So what did you have to do? You counted them up and then you told me an answer. Basically, you summed it. If there's lots of field lines going in and they are very, very tiny, how do I express that sum? By integration? That's what a sum is, right? It's just integrating when the things are very tiny. So may I write this as, oh, and then these were E, right? And if I define this area to be A, then may I write this is the mathematical expression for writing how many lines are passing through this area? Because what you did fundamentally was, yes, you counted them up, right? But what you did was you said, oh, one line passes through this area, another one passes through this, and another one passes through this, and you just counted them up. That, in fact, is called nothing other than flux. Where dA is actually the normal to this area. And that is what flux is fundamentally. Now that's one example. What about if you have a closed surface? Suppose this is my surface. And I have field lines going through. How much flux is in this case? So the field lines are passing through one side and they're going out the other side. What's the flux? 0. Good job, Nick. There's no flux in this case through the closed surface. Now, in order for this surface to have a flux, what do you need? Charges to exist inside the surface. And these charges need to be providing a field. Now, how do I find the flux through this area? You count up all the field lines outside and you sum over dA and you're done. Does that make sense? Okay, so we're going to go back to our original. So the flux through this surface area will be, count up the E's, do it over the area, and you're done. Okay, let me start by the simpler case. Let me start with one charge in here. Let's say charge Q, sitting inside. What's the flux through this surface? Calculate the flux. Phi will be integration E dot dA. One charge, field lines going outwards. Bad drawing, you guys do a better job. What will this E be? 1 over R squared. Say this radius is R and the charge is Q. What will this dA be? It's a sphere. So spherical dA will be R squared sine theta d theta d phi. And one integration becomes two integrations. Going back to the surface area of a sphere. This is why that was so important when we did in Newtonian. We better remember these very quickly. If we don't, revise them. Chapter 1. And this is going to be, R squares are going to get canceled. And I'm going to be left with Q, which is just a number. Oh, and we should have a K somewhere there too, right? K. Q. Integration over sine theta d theta. Integration over d phi from 0 to 2 pi. And from 0 to pi. And this integration leads us to 2, and this leads us to 2 pi. And what do I have? K, Q, 2 times 2 pi. Anyone remember what K was from intro? 1 over 4 pi epsilon naught. So what am I left with? 4 pi epsilon naught Q, 4 pi, or flux equals K over epsilon naught. Or I can also write E dot dA equal Q over epsilon naught, where Q is the charge enclosed in the surface, and this has to be over the closed surface. And we call this, drum roll, the Gauss's law. Woohoo! Also, I want to show you something else. Do you remember chapter 1? we did this. We're going to use this again. So does the right-hand side look very similar to what we just wrote? So may I rewrite what I just wrote equal to the left-hand side? Okay, I'm going to go back to this. So that means I can write E dot dA equal del E d tau. Do you remember us talking about faucets and things coming out in chapter 1? Does this look familiar? Woohoo!